there, my name is Edgar Dexas Nyamonyo. My email is edgar@dexasedgar@gmail.com. I'm a physics teacher and I'll be taking through physics, that is from Form 1 to Form 4. And I like as we start from the topic uniform circular motion. This is a topic in Form 4, and it's a topic that needs a lot of information. That is some prerequisite information from linear motion, that is in Form 3. Linear motion, you learned about the linear velocity, and in this topic it is going to be applicable. So if you've not understood the linear motion, you can go back in Form 3. That is the first topic. You can go back also to Form 1. It will help us to get some information under force. Also, for those who are taking mathematics, and I think it's compulsory in high school, it will be nice if you look at angles and read more on the circles. The definition of that is parts of the circle. We have the arcs, angles subtending by the arcs. So if you have those information, it will be simple for you to understand this topic. Now, circular motion is a combination of two terms. That is, we have the circular and the motion. Circular comes from the word circle, so that is something that is round, and motion comes from the verb move, meaning that circular motion, something that is moving in a round path, or in a round, we can call it movement in a circular path. Now, in this definition, you can conclude that circular motion is the movement of an object or a body along the circumference of a circle. Other people, they take it as a rotation along a circular path. Now, in this motion, we are going to look at objects moving around. It's not as the case in linear motion, where we were looking at a vehicle that is moving on a straight line, or is just moving on a specific path, and we can trace it. Now, in this topic, the bodies or the objects. Now, we can assume a body here. It can be even a vehicle, which is negotiating a pen. We can also assume objects like stones being tied in a rope. Now, those are objects. So in this topic, we are going to look at objects that are moving around, not as in the case in linear motion. That is what I want us to take note of, not as in linear motion where objects were moving on a straight line. So we can find the velocity, we can find the speed. That's what we were doing in Form 3 linear motion. In this specific part, we'll be looking at specifically bodies moving in a circular path. So we'll be looking like things like angular velocity, angular momentum, angular accelerations. We'll be looking at the angular displacements and what have you. So everything we'll be looking is at around a specific path. Take note of that. And now let's look at examples of circular motion. One, we can talk of examples. We can talk of a ceiling, fans, plates rotating around a hub. Now, if you go to those permanent houses, most of the people, they have installed fans which are helping them to cool the house. Now, if you look at those fans at the ceiling, they are always rotating. I think the electrical, somebody switches on, and then the electricity helps it to rotate. And in the process, if you look at that fan, it is rotating around. So it's maintaining a certain path. If you can trace it, you can get it is a radius. And remember, one thing about circles is that if you are looking at a circle, it must have a radius. So, and the radius is constant for any circle. If you can remember also the definition of a circle is just a locus of points that are equidistant from the one main point, and that is the center. That main point we call it a center, and if they are equidistant, it means that the point from the center to end point on the circumference, that is the radius, and that distance is constant. I think we will be looking much on it as we move by. Now, if you look at the ceiling, let's come back to the ceiling. You realize that the fans is rotating, and the blades are just those protrudings that are coming from the fan, and when they are rotating, they are keeping a certain distance. Another example is when you are in practicals. I think you performed some experiments on the pendulum, and what happens is that you tie a stone, or it can be just a small metallic object. You tie it and then you while it, or you swing it, and then you'll be counting those movements. You call it cycles, you call it one complete cycle. If you realize that that pendulum or that stone, it traces a path that is circular. That stone traces a path that is circular. Now we can take that rope to be our radius, and as you see, that rope is just constant, it's not changing. And you see also the stone, it is being swirled, or it's being wild, or we can use the term swung. It's being swung by a certain force. So you apply a certain force, or you pull it. You can pull it or push it. In the process, it will be swinging. In the process of swinging, it is tracing a certain path that is circular. And in the process, we say that it is in circular motion, because one of it is moving, another thing it is tracing a circular path. Now also let's look at another example. For those who are watching TVs and movies, you've realized that we have car racing, where you vehicles negotiate sharp bends or sharp corners. Now, if we can stand at a certain point and trace a point, we can realize that it is a curve. Now, another example of the same cars negotiating bends, you can go to the in a junction. You realize that there's a roundabout, and that roundabout it is in circle, so that the vehicle comes there and it negotiates, or turning through a curve, and that curve is being traced as a circle. Now, that car that is negotiating that bend, we can call it negotiating that bend, or is just turning through a curve, and that curve is in our pocket. We can put a roundabout, because that is what you have used to most of you. So that is a curve, and the vehicle, we say it's moving in a circular path, and that is circular motion. Another example 4, we can go to also for those who have studied or they are taking geography. You may realize that some astronauts, they take some artificial satellites, some cameras that they send to the Earth, and those cameras, they help to take some pictures of the Earth, and in the process, the satellites, all those cameras, they are made in a way that they move around the Earth at a constant height, because we have to keep the height for it to be there's a reason as to why we are keeping it at a constant height, because if the height is different, then they will not be in the same or they will not be coinciding. Even the pictures will not be specific from the Earth. So those objects, they are sent there, they just rotate around the Earth. Not only the Earth, it can be also other planets. So they send those satellites there, they just pick pictures, then they send it back to the center of the station for analysis. So for those who have seen also some movies, you saw some satellites, or you can get some clips showing you some satellites. They are sent in the space, and they keep rotating, not rotating but revolving around the Earth at the same height and at the same uh, speed, so that there's something I'm concentrating on a constant height. As time goes by, we'll see it, but for now, just know that there's those satellites that are sent to the Earth, and they are revolving around the Earth at the constant height. Example 5, we can take a child playing in a merry-go-round. For those who have gone to the shows and exhibitions, and for those who like going outings, you realize that children are given they are put in a merry-go-round, and in the process, the merry-go-round is being switched on, and they start rotating in a circular way. Not only that, for those who like swinging, I mean those who like tying a rope at the tree, then they swing at home. That is also another example of circular motion. The examples is not limited to anything. You can take also for those who like riding bicycles. You realize the bicycle is has two wheels, and I can take the last wheel. The wheel is just rotating, and it is moving. So in the process of moving, it is tracing a circular path, and that circular path, and it's moving at the same time. That becomes our circular motion. So in this topic, we'll be looking at most of the objects or bodies that are going to move in a circular path. For that, we conclude that uniform circular motion occurs when a body is moving in a circular path at a constant speed. So for it to be uniform, that's why we introduced the term uniform. Uniform here, because there are those who are keeping on changing motion or the speed. Here we conclude that when a body is moving in a circular path at a constant speed, then that is uniform circular motion. Take note of at a constant speed. Take note of at a constant speed, because this is more important in our topic. Thank you for watching. Let's look at the next clip. Thank you.